we generally talk about two types of databases, right? We talk about your OLTP and OLAP, right? What is OLTP? OLTP stands for online transaction processing, right? And OLAP is online analytical processing. Okay, that's the only difference, A and T. What is A and what is T? Okay, transaction means when you are doing live database. Okay, let's say you talk about Amazon database or any application where you are recording day-to-day activities, right? Login, somebody wants to buy something, they want to change their let's say details. Okay, so all the data is available online and people can use it. But analytical processing, OLAP, is a database which is taken. It's a subset of OLTP. Okay, now you want to analyze data of say November 2023. Okay, what happened in the month of November? So we break in terms of some dimension. Okay, we want like in this case, you want to understand complete business for November 2023. So your dimension becomes time, and looking for November where time equal to November 2023. Okay, you take it and then you analyze it. Okay, so when we talk about data analysis, business intelligence, warehousing, data science, machine learning, they all work on OLAP database. Okay, where you have taken the data based on the context. Based on the context, it could be multiple dimension. Okay, you want to analyze, let's say, only Asia Pacific customer for November 2023. So you have time, which is November 2023, and you have geography dimension as well, right? Geography also you want to measure, you want to analyze for like in terms of Asia Pacific. So you will have multiple dimensions and you'll be getting data on multiple dimensions, right? And these are not live, this is not available to everyone. Of course, database is not exposed to everyone, right? You can only see data which you have access to, right? So when you log into your Amazon account, you can only see the data that you have created, the items that you have bought. You can't obviously see mine or somebody else, right? You will only see things which are given to you as access, for which access is given to you, right? And OLAP is generally done by these data scientists who would, or data scientist who would require to work with the specific data, right? So that's the purpose of um, your OLAP databases. Now we need to understand a little bit of OLTP. Okay, we need to understand what database are, right? We have different types of databases, but the still like bulk of the database that is used in the market is called RDBMS. So you have DBMS, which stands for Database Management System. And as I said, there will be multiple types of database management system, but the most commonly used is RDBMS. Okay, what is R in RDBMS? It is the relational database management system, right? That's your RDBMS. This is generally used for tracking and storing structured data, right? Why do we need a special software? Why do we need a special software? You can do it in Excel, Word, right? But we need a special database because it's not about storing, but it's also about accessing. Okay, and accessing a specific data from Word, Excel becomes very difficult. Okay, so we need a database which can store TBs of data, right? And also accessing data from this database software should be easy. Now, how do you access this data from database? So we have language for database called as SQL, right? So you have SQL. Now, SQL is a language, okay, stands for structured query language. The SQL, okay, is a language. So we say language of database. Okay, we say language of database because here, you will uh, use this language to query or get the data from database. So now all the RDBMS systems, okay, whether it is Oracle database or SQL Server database, MySQL, Postgres, there are tons of databases, and all of them they use SQL. And SQL command, almost like I would say 95, 99% are same because all these database, RDBMS database are are they have to follow your ANSI standards. Okay, ANSI standards sets the standard for SQL, so every database has to follow. So though their physical structure could be different, physical means the way the company will create the software, right? Ultimately, it's all files only, isn't it? So they'll have different files, they have different ways to install, but logically, all of them behave same because they all have to follow ANSI standard, right? What ANSI says is data should be stored in table. That's the logical storage. And then you can use select query to read the data. Okay, so you have queries like select to read the data. If you want to add data to the database, you have to use insert. If you want to modify something, so you have to say update. You want to delete the data, then you have to use delete. Right? Then if you want to make, you have to create a table, right? You will use create. You want to drop, remove the table. So not only table, you can create other database objects like your trigger, your views, things like that using create and drop. Okay. But as a in database, there are three types of role that exist. One role is database administrator. They are responsible for installing, taking backup, making sure the database is up and running. All the maintenance activity is taken care by DBAs. Okay, so we are not getting into DBA role. That's a different role. Then second type of role is about being a database architect. Okay, so based on the requirement, you will work with the application team to understand how many tables. Okay, what should be the column, what is the relationship between those columns, right? Now, those are again we as a, from the Python perspective, from application perspective, or from data analyst perspective, we don't get into too much of that, but that is required because if you cannot create a table, we cannot add, right? So of course, right, we will learn little bit of create and drop. We'll create our own tables which we will use. But as I said, we don't have to get into too much into that. Okay, if you want to make career as database expert, then yes, you have to understand, have to get deeper into SQL query and this. But from our perspective, we just need to know these: select, insert, update, delete. And if you are a data scientist or data analyst, then you'll be focusing more on select only. Okay, so select, but the most uh, in terms of learning, select has more things to learn than any other anyways, right? So if you want to become an expert in SQL query, you have to spend time on select. And as a data analyst, of course, you'll be using select query to read data from one table, to read data from multiple tables. Okay, that's what we are going to see. Now, how do you get data from multiple tables? Because these tables are interlinked, they are related. That's why R in RDBMS, R stands for relational. Okay, so two table will be related to each other. Now, let's say I want to create a table with employee record, right? I want to create table with employee record. So I can create a table. Okay, so I'll say table employees. Now, your SQL queries are case insensitive, unlike Python. Python is case sensitive, right? Lowercase, uppercase, they have different meaning, but in SQL, it is case insensitive. Okay, so there is no difference between upper and lower cases. So you have table employees, and let's say I want to store data like employee ID, say employee name, let's say employee phone number, employee email. Okay, and also I want to store which department employee is working. So I'll say department. I want to know the department head, right? Department code, right? Right. So let's say these are the things that you need to store. And let's say I also want to know department location. Yeah, the location. Now you see, if I say employee ID 1, name AA, phone number 123, email aa@aa.com. Okay. Now I say department is finance, or I'll say executive. Let's say I will assume this is CEO. Okay. Now department head, okay, would be another person, right? Now let's say department head in this case is AA itself. You go to department code, right? So let's say department code, I say E01. And department location, in this case, let's say there is only one head office you have, right? But then there could be location, multiple location as well, right? Now, this fellow would be sitting, okay, the A is sitting in, let's say, NY, right? But there could be another person, okay, let's say employee 2, okay, which is AB, okay, 223, okay, ab@aa.com, okay, again executive, and department head is AA, department code is E01, and let's say this fellow sits in ML. Now you see, okay, now a company will have hundreds of employees, right? Then how do you manage this? How do we manage in one table? Can we manage in one table? Now you see, tomorrow, okay, department code changes. Now you might have 20 executives. You talk about product development, you might have 2000 product development people. Now for 2000 product development, you have same department, you have same head, you have same department code, right? And you will have multiple location. Now I want to know which all location this department is. I cannot know. I know where AA works, but can I know by looking at it which department, where all the location the executive is? I don't know, right? And now let's say if the department code changes, department head changes, okay, I have to change 1000 record, right? It is taking more space. It is, more than the space. Of course, space is also concerned because we're talking about TBs of data. Unnecessary, if you keep on adding information, it becomes even more complex, right? That will slow down your reading also. And updating is a pain because you don't know, okay, how many rows to update. If I have to change department code, I don't know which all department code I have to change. So this is where your relationship concept comes into play. It says that let's break this data into multiple tables. Okay, let's break this data into multiple tables, and based on the relationship, we have to link those tables one, and then when we get the data from multiple tables, we will use this link. The linkage that we will create, this will help us to jump or connect two different tables. Getting data from one table is easy, but getting data from two table may not be that easy. We have to do something special. So, again, this takes us to set theory. If you remember set theory, you have relationship, right? In sets, one to one, one to many to many. Remember? What is one to one relationship? Let me give me a second. I'll move on to paint. Okay. Now let's say you have, okay, you have on one side, you have e-name, employee name. Okay. These are your employee name. And let's say these are your email. So see, you have employee name, employee name, employee name, employee name, and this is email ID, email ID, email ID, email ID. Now, every employee will have one email ID, and every email will have one employee ID, one employee only. Correct? So, one email will be linked to one employee only. So, here you have one, okay, one value coming here, and here you have one value going this side. So, we say it is one-to-one relationship. So, in this case, employee name and employee email is like one-to-one relationship. And when you have one-to-one relationship, we put them in one single table. So that means when we create employee table, your e-name, email, all those values which have one-to-one relationship will be in one single table. Okay. Now let's look at another example where you have e-name and department. E-name and department. Right? Now e-name you have, let's say here, and department, obviously you'll have less department, right? Employees will have in thousands, department could be in tens only, right? So now I'm saying that this employee belongs to this department. Let's say employee 1, name 1 belongs to one department. This employee belongs to this department, right? This could be finance, this could be HR, this guy could again be finance. This guy could again be finance. This guy could be something else, new one. So what we see here, from this side, one employee will have only one department, isn't it? One employee cannot belong to multiple department. So from this side, you have only one. But when you come this side, one department goes to many employees. So here you have many relationship. So we say one to many. And when you have one to many, or see, one to many or many to one is same. From employee name to department, it is one to many. From department to e-name, it is many to one. So one to many or many to one, it means same thing for our understanding here. So what it says is create two table. So create employee table and create department table, and then you link them. That case department will have only those 5, 10 department that you have, and this will have only 10 times. So if you have to change department owner, you can easily change, right? You don't have to change multiple rows, you will change only one row. But here in the one that we designed earlier, you don't know how many, definitely more than one, but you don't know how many. It could be many, right? Or many, right? So what we say is when you have one-to-many relationship or many-to-one relationship, then we create two table and we link them using foreign key. Tomorrow we'll talk about what foreign key is. And we will create foreign key. So when you have one-to-many or many-to-one, we create two tables. A third example, you have location and department, right? So your department will belong to multiple location, right? Product development could be in 3 different location. Now, one location may not have only one department. It can have this department, also this department, right? This can also have this department. So what you see is many to many relationship you see. Many department will have same location. Many location will have same, or one location will have many department, or many location might have one department also. So we see it is many to many relationship. So when you have many to many relationship, then we create 3 tables. So you create one independent table for this, you create one independent table for this, which is location, and this will be your department. And then you link them using foreign key. So this table, third table, will have linkage to this table as well as this table. So this table will have 2 foreign keys, unlike here, which, two tables, one table will have the linkage to other table. Here you have 2 independent table and both of them should be linked via third table. So when you have many to many relationship, we talk about 3 tables. Okay. So we'll stop here for today. Tomorrow we'll take same